Thanks everybody for coming to this session. My name is Sveum. I'm the solution lead for our information availability product in EMEA. And with me today I have Abhijit. He's our engineering lead for all of our storage products in Veritas. We're going to talk to you about a new offering that we have been busy building in secret for the past 3 to 4 years. We call it HyperScale for OpenStack, and obviously it's a storage solution for OpenStack. I'll share with you some thoughts on what we're gonna, why we've done this, and where we think the opportunity lies within OpenStack. Then we're going to talk in detail about the architecture. We're going to show you some demos. We're going to share with you some technical aspects, and of course, Abhijit is here to provide his perspective, of course, on any technical, detailed questions that we might have. So, why OpenStack? Why now? Well, first of all, we see a trend within IT to start to adapt to private cloud architectures. And we see a desire to do so with an automated and orchestrated platform. And OpenStack provides that. It also does it so with a loosely coupled architecture, which is actually also another aspect that customers want. When we have tight integration and orchestration, where we have orchestration and automation embedded, but with a tightly coupled architecture, there's no capability of scaling out efficiently or adapting your architectural workload to whatever design you need. Finally, but not necessarily lastly, OpenStack is awesome, right? For those of you who've been around for a while, you've seen OpenStack grow for the past 10 years. This is an excellent platform. It is community-driven. It has a strong foundation behind it. Pretty much anybody who's anybody in IT, whether it's with a network, computer, storage, or service, is a part of the OpenStack foundation. But the real drivers behind it are the community. We're driving the roadmap. We're making the decisions for how and which features will be a part of OpenStack in the next release. And it is starting to become commercially viable and useful for large enterprises. These are just some examples that I pulled off of the OpenStack user group, but there are lots of them now. Now, that doesn't mean that OpenStack doesn't have challenges. We still do have lots of different challenges that we haven't met yet. And those are some of the key things that we are hoping to try and address. So, what's really driving the adoption, and what are customers really looking for when they talk about or think about adopting OpenStack? This is from the OpenStack user survey that was published for the summit in Austin, so back in April. The number one priority for adoption is to save cost. And to save cost based on the infrastructure that you're going to put together. To my mind, that means I'm going to put together an infrastructure that's going to be commodity. So x86 servers, I'll leverage local storage components, and I want to scale out architecture. In other words, I don't want to scale up architecture where I have to purchase all of the required hardware, compute, memory, and storage components in advance, something that's going to be very difficult for me to change over time. Now, that means that I need to make sure that I have a workload that it can scale out as well, right? I need to make sure that whatever platform I build underneath, leveraging that scale-out architecture, is going to adapt to that workload. But what if my workload isn't designed that way to begin with? What if my workload is really a scale-up one? How can I use this architecture still? The second one is, how do we increase the operational efficiency? Now, there's a lot of automation or orchestration already embedded within OpenStack. But there are some key things like simplified storage management. Simplifies ways of managing things that we think of from an enterprise perspective as key. Resiliency for storage. Resiliency for VMs or applications. Not to mention backups. And recovery. These are enterprise operational things that aren't necessarily taken into account. And then finally, leveraging the same platform, the same storage platform, or the same private cloud platform to allow me to take advantage of this platform to adapt quickly to a DevOps environment or to support velocity of operations. So these are sort of the 3 key things, but that's from the survey of users that are actually already using it. What about more of a real world scenario? So when I talk to customers, I talk to engineers, I talk to architects, I talk to sysadmins. So I thought I'd give you a bit of a perspective from these two angles. So architects are really thinking about, how can I architect and put together an environment where I have VM data or application resiliency. They're thinking about how can I leverage this new platform, but leverage it for my current enterprise workloads, not just the cloud scale workloads that I'm busy building or maybe have been building. I want to take advantage of this platform for everything. Finally, how can I start to leverage this platform to guarantee SLAs? Guarantee SLAs for performance as well as quality of service and high availability. This is key to be able to take your current priority one or critical workloads onto these platforms. What is the sysadmin thinking about? Well, the sysadmin is thinking about simpler things, but not necessarily less complex. How do I recover from a fault? How do I troubleshoot? Those of you who have actually deployed OpenStack know that while on the face of it, it is very agile, very simple. It is actually very complex underneath. It's got lots of different pieces of the puzzle, and not necessarily the capability of failing or allowing for automated recovery. That might actually be a feature and functionality of my application, but what if my application isn't a cloud scale application? What if it's a traditional one? And finally, how do I manage things like backup and recovery? Take it, again, back into that holistic enterprise scenario. So, we want a solution that's going to save us money while allowing us to adapt to commodity x86 workloads in a scaled out architecture, driving down the CapEx investment. We want something that's going to provide us with resiliency for both the VM, application, and our data. We want something that's going to allow us to increase operational efficiency as well as drive faster velocity of operation. And finally, we want it to perform. We don't want it to perform for extreme scenarios, but we also want to make sure that we guarantee certain levels of performance so we don't create scenarios where resource contention is forcing us to manage the performance and troubleshoot the performance significantly over time. So that's what we've built. So let me introduce you to HyperScale for OpenStack. Basically, a scale-out architecture where we use a software-defined storage virtualization solution in a hyper-converged scenario where we are taking advantage of x86 commodity compute workloads or work nodes with local storage, spinning disk, SSDs, PCI Express flash cards, but from your favorite hardware vendor. We allocate the storage directly from the compute into the VM. And in this VM, in the scenario, in order to save on the storage capability and utilize the storage resources as efficiently as possible, instead of providing you with a full version of the VM on each individual nodes, we're going to put one full copy of the VM where the VM is running, and then preserve a delta, and this will be consisting of the last 15 minutes worth of data that's been written to the VM on a neighboring node. So we'll have this east-west network that will allow us to store a full and all writes directly on locally, and then all neighboring nodes will preserve our data locally. This will give us a much more efficient usage of the storage resources in our primary compute. But you're all sitting there thinking, Peter, this isn't a fully resilient solution. No, it isn't. So we are introducing this new concept of a secondary data node layer. And we're doing it for two reasons. One, we want this primary compute layer to be efficient. Two, we want to separate all the IOs that we perform into a primary IO path and a secondary IO path. So that anything that you have to do that is secondarily, you can do utilizing a full version of the VM in your data nodes. In order to make sure that we have a fully resilient solution, we synchronize our deltas down into our data nodes on episode, regular intervals. That gives us basically a point-in-time set of copies inside of our data nodes that can be leveraged for all the various secondary data operations that you need. Resiliency, backup, supporting ETLs, data movements, etc., even scanning. also means that any operations that you perform on the secondary I/O is going to hit only your data management node, never hit your primary compute. Means you're going to avoid any sort of resource contention and the noisy neighbor challenge, which is one of those key attributes or key challenges in a private cloud environment. Key challenges in a scaled out environment, where on the face of it, you're not supposed to care where a VM runs at any given point in time. Overall, you get lower cost for infrastructure. You get lower cost for storage performance or for operational cost as well, because we've embedded all of these operations within OpenStack. So everything that you have to do, you're actually doing within the Horizon UI. And you're getting the capability of scaling granularly. Build your solution to adapt to whatever requirements you have. Scale compute and storage, both performance and capacity, to your needs. And achieve 1/4 to 1/5 the overall cost versus a traditional storage solution. Provide up to 95% storage utilization in your primary compute, and completely avoid the vendor lock-in. But you're going to want to make sure that this actually works, and it works properly. So Abhijit, how does it work?
Sure. Thanks, Peter. So, as Peter said, I'm from engineering, right? So I'll give you the engineering aspects of it. So this is Horizon. This is regular vanilla OpenStack UI called Horizon. So what we're doing in this product, the architecture you saw, is we are adding the storage persona to OpenStack. Horizon today, you might know, does not have any storage perspective. It doesn't say how much storage is used in the data center. It doesn't, right? So all of these things that you're seeing here are new to OpenStack. But this is all within Horizon. And we are checking all this code into OpenStack from Veritas. This will be our contribution. So the primary storage layer that you are seeing, that's the compute layer that Peter was talking about, the compute, scale out compute layer. The secondary storage that you're seeing here is the data management layer. So this UI shows the storage management for the entire private cloud, one single pane of glass. It also shows you performance characteristics, real-time graphs, faults, so that you can troubleshoot at a virtual machine level, at a Nova compute, or at a workload level, or for the entire data center, for all the machines that you're running, right? That's the intent of this product, to be completely akin to OpenStack, give a software hyperconvert solution that completely optimizes your storage consumptions while give you scale out compute performance. It's a new scale out platform for compute for tier 1 applications.
So that takes care of our cost challenges.
Correct.
But what about resiliency? I said we'd need resiliency as well. So take the same architecture. I've introduced you to a little bit of the challenges around resiliency. Well, let's say we have a failure. A failure in a node, a failure in a VM, or a failure on a storage resource. Well, we're immediately going to fire up that VM on one of the nodes that already maintains a Delta. And then we're going to backfill from our data node the full version, the latest full version. Remember that a Delta and a full version on the data node is always equal to one full copy of the data set. And we allow you to maintain the level of resiliency or protection that you require. So as you spin up a VM, within the VM flavor, you've already defined how many neighboring nodes am I going to maintain a Delta on. Is it going to be 2? Is it going to be 3? Is it going to be 4? Whatever. However paranoid you are. And also, how many versions of that am I going to maintain within the data node? Am I going to have 2 generations every 15 minutes? Am I going to throw away and just keep 1 every hour? What's my requirement here? What do I need in order to recover efficiently? This gives you basically an automatic recovery from the various storage and node failure scenarios that you may have. But we thought we'd also show you the key functionality that actually provides you with the capability here, and that is a live migration feature. So within OpenStack, you have the capability, leveraging KVM, when a crash occurs, we can immediately resilver that, or sorry, not resilver, but rehydrate that VM.
So that's actually correct. So while you're going to roll a video.
Yeah.
Okay, so this is a real operational model of the product as it is today, showing live migration again, this is similar to, for VMware folks, it's the same as VM live migration, vMotion through a vCenter.
So
Right?
to illustrate, we're running a video in the background while we are performing the live migration functionality.
Yeah, so what it shows is one virtual machine which has a Windows image. It's running, we picked a real live video, and what we did is we are running the video. While the video is running, while the movie is running, we are going to live migrate the virtual machine to a different virtual machine like Peter was talking about. Now the data and the application data and the application itself is moving from one physical node running a virtual machine to another physical node running a virtual machine. While the data moves, the data is rehydrated back from the data management node, making sure that your application continues on while on the back end the application is moving, is live migrating. That's pure resiliency for you. So you can maintain your VM and recommission them as you need them.
And this is a capability that we're doing, or we're giving you, leveraging a hyper-converged environment. So remember, there's no shared storage backend. It's just local storage, which is shared between nodes. All right.
But, the video is only reading data, not writing.
That is true in this example, but it would have worked exactly the same way. The video is more sexy because it allows us to show that, but absolutely true. But writing wouldn't have mattered.
Because the last 15 minutes of Delta image is also in the compute node, the other compute node. So when the the application would move, it would also see the writes in your application, would also see the writes in the new node. So we choose the node to live migrate on based on who had the writes before.
And writing during the migrate is also possible?
Writing is always continuously happening to the synchronous nodes. So the migration happens to one of those replica nodes. Go ahead.
Can I have a question?
Yeah.
When the VM crashes, then you have downtime in this solution, right? Or am I incorrect?
No, there's no downtime because the data is already there in the other VM, which sits in the other node. You could have a full storage failure. Instantly, the Nova live migration, the Nova APIs which you tap into will sense that there's a VM crashed. So the Nova API will provision and orchestrate the VM on a different node where the data is already sitting. So there is no VM crash here.
So let's take one step further. Operational efficiency. We've covered cost, we've covered resiliency. I want to talk about providing increased operational efficiency and supporting velocity of operation. Well, in this data plane, we have the capability of leveraging these point-in-time copies to support ETL and DevOps processes. They're inherently there so you can, as an end user in a project, take a copy of the data and re-provision it to another VM. That can be a full instantiated VM, or it can be a portion of that VM. We understand that the VM may consist of multiple different volumes, you may have multiple different data sets. There's also another challenge, another key challenge that we're addressing here, and that is in a scale-out scenario, one of the key challenges is how do you manage resiliency between multiple VMs? In other words, in a scale-out scenario where you have a MongoDB or a CouchDB running across 10 VMs, how do you ensure consistency across those, both for resiliency as well as for reprovisioning? We understand the nature of how VMs relate to each other as well as the data set and can maintain that consistency across compute nodes. So you can actually reprovision an entire scaled out application set. We've also recognized that you're not going to maintain the data inside your data management node forever. It's not meant to. Maybe it's there for 5 days or 3 days, so it'll fulfill that near-line or near-term recovery perspective. But over a longer term, you're going to want to be able to move that data out into a second or tertiary storage layer. That tertiary storage layer may be S3, maybe Ceph, or it may be a backup solution like NetBackup. The key, though, is that from a management perspective, this is being managed by the end user. As an admin, you set the policy. You set the policy for the resiliency level, the number of snapshots you're going to maintain, how you're going to move it to a tertiary level, as well as where it's going to go. So you have that automated management of the data lifecycle of a VM. But the end user is the one who's managing and maintaining the recovery process. So we'll have that visible to the end user within a project. He'll be able to recover a VM regardless of whether it's maintained inside the data management node or in the backup or tertiary layer. So we give you a full-fledged storage management solution with policy-based storage provisioning. We've automated the placement of the VM and the data. We know where, in accordance with your policy attributes, the data should lay. So we automate that placement, which is another key attribute of a private cloud scaled out architecture. We maintain the version storage to support DevOps and ETL processes. We provide you the capability of embedding the lifecycle for backup or for archiving purposes to another layer. And we also do this in a way that allows you a zero data management window. In other words, a data management window that will never hit your primary compute. It will always be through your data management nodes.
So, so like Peter said, again, this is all through OpenStack. So when you create a virtual machine, you can say, this is my virtual machine, I'm going to run Oracle on it, or some tier 1 application. And you're going to say, I'm going to back it up. So you are going to put the backup policy during the creation of the virtual machine into the software-defined template. In your backup provider, you're going to mention this is the backup policy for this VM. And after that, there is no other work to be done. You don't have to provision a management window. You don't have to quiz an application. You don't have to take a snapshot. You don't have to run an agent. This kind of solutions in OpenStack does not exist today. So this is a way of backing up your OpenStack private cloud through this product. Right? That's the simplicity and the software-defined storage that we should be doing in OpenStack today.
Another key challenge when you think about private clouds is quality of service or performance in general. That also applies to hyper-converged architectures as well, ensuring that you're avoiding the noisy neighbor challenge. We do this by allowing you to mix and match the type of storage that you have inside your primary compute, requiring some levels of flash as well as spinning disk. And then always writing to flash and making sure that we have optimized that software-defined storage layer for random I/O. So we're not tied to any individual uniform I/O pattern. You can actually mix and match the type of applications and workloads that are running inside this private cloud environment. We also allow you to maintain that through a set of policies. So remember I talked about how you set the levels of resiliency and the life cycle of data inside the flavor. You do the same thing for the quality of service for performance. So you basically set the level of performance that you want that VM to have at the time of creation. Maximum IOPS, minimum IOPS, etc. We also optimized the data management node for sequential read and sequential write. Since you're always going to be writing to it sequentially, while all these episodic data syncs are going to write in parallel. And the same thing for reads, right? You're always going to be reading in sequence. This optimizes performance overall, giving you quality of service for I/O, for performance, then delivering increased utilization at scale holistically. But we got to tell us exactly how this actually functions.
So within each compute node in the scale-out compute, we have a thing called VSA, which is our storage stack. It's a user stack, not in the kernel, on the hypervisor, sits on the KVM, and that's how the architecture looks. The I/O comes in, the synchronous replication happens to the peer compute nodes. The data either goes to the flash or the internal hard disk, and every 15 minutes or so, like Peter was talking about, there is an asynchronous episodic flush into the data management node. That's the architecture that is in your compute node. That's what makes it happen. If you go into the next one, Peter, so this is the quality of service. And for Veritas, we understand storage. For last 20 years, we've been doing software-defined storage. So what we thought about here is quality of storage is an unsolved problem in OpenStack today, especially when it comes to commodity flash storage. So what we do is we take applications as they come. So in this case, we have 3 virtual machines running, VM1, VM2, and VM3. And we look at the application's priority. Like Peter was talking about, you can set a priority of an application. You can call it gold, silver, bronze in OpenStack language. And based on the priority of the application, we assign it a weight. We call it a priority weight measurement. Based on the weight measurement, we decide who gets to write to the disk faster. If it's an Oracle, which is VM1, he will write faster than a noisy neighbor, which is VM3. And because we have assigned the priority based weight by our quality of service algorithm, we can design that Oracle gets to write while that noisy neighbor is eliminated. This is pure quality of service at the destination, which is the storage level. OpenStack doesn't do it. OpenStack does it at the compute, which is the virtual machine level. So it basically all it does is throttles the the CPU and the memory utilization. But QoS, quality of service, should be done at the storage layer, which we are trying to do here.
So it actually solves this challenge of how you manage performance overall in private cloud within an OpenStack environment, which is actually something that we try to do today, and for instance in VMware. But we do it with great difficulty. If you do have a challenge, you actually choose which VM to place on which ESX server. You try and mix and match to make sure that nothing is competing for resources. We built an environment that allows you to basically trust that you're going to get the level of performance that your policy requires.
Yep.
And just let that VM fly out into your private cloud and get that performance level.
And just to add to that, if you look at some of these solutions, like from an engineering perspective, Commvault and other solutions, we will do a QoS at the SAN layer, at the all flash layer. That's behind Cinder. That's not at the flash. This is a solution trying to do quality of service at the compute, right where the I/O is happening on the flash. That's the differentiation.
We thought we'd show it to you.
Okay,
so
sure.
just so you can actually see also how this functions from a performance perspective. So
Sure.
here we're actually walking you through a functional version of Red Hat with our HyperScale for OpenStack embedded. We have 8 compute nodes. We can see the various management aspects with the primary and the secondary storage. We have 2 data management nodes, and in a little bit we're going to start to fire up some VMs and we'll start to consume. It'll be a mix of read and write.
Yep.
We're
70/30.
using space.
Yeah, so basically this workload is running industry level benchmark, sequential read-write 70/30 on 10 virtual machines per node, so that's 80 virtual machines in the private cloud, writing to 2 data nodes, right? And we are going to run the application workload right now, and then it's going to show that the application compute I/O performance is going to build up over a period of time, right? So that's going to show you as you scale out your architecture, not just scale up, as you scale out your architecture and run application workload over a private cloud, will your performance be also at scale while maintaining that storage optimization, that resiliency, that zero backup window? That's the whole idea here. So as you can see here, the application has started, the load has built up, or it's starting the application, and at this point,
Now it's starting the load.
now we're starting the load on each of those virtual machines, right? So this could be your tier 1 applications. This could be Oracle. This could be Cassandra. This could be any other application that you choose. And you can see that the IOPS, which is seen in the Horizon dashboard, is now building up. Now, if you look at this competitive architecture, which we have today, the Nutanix, the vSAN, the Scale IO, and all these other architecture, they won't be able to produce this kind of performance and IO per second because they are not proper scale out. They have multiple copies in the compute cluster. They don't have a data management node, so their compute cluster is doing all the operations, primary and secondary storage operations, and are extremely burdened by doing those. Here, in this kind of architecture, the compute is only serving IOPS. And in a pure computer science, that's what a compute is for. So it's a pure scale out compute performance intended for tier 1 applications, which ran extremely well on your earlier VMware architecture, but that's not cloud ready. When you go cloud scale, that's the architecture which will take you to the scale out performance with resiliency. And we are almost there. We are building up the applications. So the performance is going up, as you can see. And we intentionally did this. So as you bring up more application workload, the performance is going up to 1 million IOPS when it's done, right? And as you can see, of course, it's a scale out architecture. This is with 8 nodes. You could scale up to hundreds and thousands of nodes with that kind of linear scalability, both in the primary and in the secondary storage plane.
And as you can see, we actually have tested it to scale up to significantly higher performance. That was a demo we tested just a few weeks ago, but here we go.
This is 3 million IOPS.
We're running out of time. I want to make sure that you guys
Okay.
understand. We've started this project many years ago, and we've kept it close to chest because we want to make sure that we get it right. We get a good solution for you. Now we are announcing it holistically, and we've embedded this capability into all the various components of OpenStack, providing Nova Compute with intelligent placement as well as modification of the virtual storage pools for direct attached storage, giving quality of service for Cinder, and storage utilization, storage management, simplified storage management within OpenStack. This gives you a capability of saving money by adapting out hyper-converged environments, scaling out using x86 and local storage, giving you the capability of simplified storage management that allow you to increase the operational efficiency of your environment and support those DevOps processes, providing you with the resiliency you need, as well as the performance you need, and key embedded mechanisms for managing that. So this is our solution. I'm going to skip to the last slide so we have that key aspect here. Come to our booth and do our survey, and we'll get your chance to win a GoPro. Ask us some key questions. We're more happy to answer them.
And we are also inviting you to Barcelona. We have special booth and dinner arrangements. If you're coming to Barcelona, please join us at the Veritas booth there. We'll be more than happy. Personally, I'm extremely happy to be in Amsterdam, third time in my life. And thanks for being a great audience.
Thank you.